Okay, let's dive right into this explainer with a truly massive foundational question. How do complex systems, and we're talking everything from tiny biological cells to giant human societies, actually build themselves without a grand designer? It's a puzzle that has literally challenged scientists for decades. Well, today we are unpacking a groundbreaking paper by independent researcher John Cantillo, which aims to answer exactly that by exploring a fascinating framework called recursive constraint reorganization, or RCR for short. Here's our roadmap for this explainer. We're going to build this from the ground up, starting with constraints and structured possibilities, moving to the minimal RCR mechanism, looking at building constraint architectures, climbing up the hierarchy of complexity, and finally, observing these systems in the real world. Section 1. Constraints and structured possibilities. The foundation of organized systems. So, to really get this, we have to strip away all the mind-boggling complexity we see in nature and focus on the absolute bedrock of organization. It's incredibly tempting to look at a complex system, like a car engine, a living cell, or a bustling city, and think its physical parts are the source of its organization. But this paper argues something deeply profound. Organization actually begins with how possibility itself is structured. It's not just about what is happening right this second. It's about what is structurally allowed to happen next. Now, I know what you're thinking. In everyday life, a constraint sounds like a totally bad thing, right? A roadblock, a limitation. But in systems theory, a constraint is the very thing that makes organization possible. Think of a riverbank. Yes, a riverbank restricts where the water can go, but in doing so, it simultaneously enables the organized, directed flow of a river. Without the constraint of those banks, you just have a shallow, unorganized puddle. The constraint is what actually structures the possibilities. And this is a really crucial distinction to keep in mind. If a random rock falls into our river, that's just a generic causal influence. It's a one-off splash that alters a single outcome. But an organizational constraint, that's like the permanent curvature of the river valley itself. It's a persistent condition that systematically shapes what we call the trajectory space. It basically dictates the entire menu of what is dynamically possible over time. Section 2, the minimal RCR mechanism. Reconstructing possibility. Now that we have a grip on constraints, let's see how they actually evolve, which brings us to the beating heart of RCR. First, a prevailing constraint dictates what is possible. Second, an activity actually takes place within that structured space. Third, and here is where the magic happens, that activity ends up modifying or reconstructing the very constraint that guided it. Finally, that newly reconstructed constraint now dictates what the activity can do in the future. It's this continuous, self-modifying loop. Cantello puts it perfectly here. It's all about the return of consequences. To jump back to our river analogy for a second, the flowing water is guided by the riverbank. But over time, that fast-flowing water erodes the bank, right? By eroding it, the water has actually reconstructed its own constraint. Because the bank now has a completely new shape, tomorrow's water is forced to flow in a brand new direction. The activity altered the constraint, and then the constraint altered the future activity. But how do scientists actually prove this loop is happening in the wild? The paper highlights a critical counterfactual test to prove RCR is genuinely at play. You have to ask, if you removed that newly reconstructed constraint, would the trajectory space, the whole realm of future possibilities, systematically change? If the answer is yes, you have true organizational relevance. You aren't just looking at random history anymore. You're looking at a system that is actively rebuilding the rules of its own future. Section 3. Building constraint architectures, from multiplicity to organization. Let's see what happens when we scale this up from simple loops to intricate webs. Having a bunch of constraints all acting at once is just called constraint multiplicity. Think of throwing a handful of rocks into a stream. They all affect the water, sure, but they don't really care about each other. True constraint organization only happens when those constraints interact and depend on one another. Their collective arrangement, their architecture, becomes a unified force shaping possibilities in a way that just adding up the individual parts could never explain. Now, as we look at these complex architectures, brace yourself for a bit of a twist. Systems don't inherently want to evolve into something better or more complex. The scientific term here is teleological agnosticism. Essentially, RCR is a completely blind, outcome-neutral mechanism. The return of consequences can absolutely build a thriving, vibrant ecosystem, but it can just as easily fragment, simplify, or completely destroy a system. It's a mechanism of change for sure, but definitely not a predetermined path to perfection. Section 4. The hierarchy of complexity. Stacking the conditions. Cantelo identifies 6 specific levels of complexity. Now, it's super important to note that these don't represent some universal timeline that every single system has to perfectly follow. Instead, think of it as a spectrum of analytical complexity. We start at level 1 with our simple riverbank, move up through RCR and organized architectures, hit level 5 where constraints actually mutually maintain each other, meaning the system literally fuels itself, and finally arrive at level 6 where entirely new, self-maintaining systems emerge. Think of a living cell organizing itself from simple molecules. Mapping all these relations out, from minimal constraints all the way to emergent regimes, is, frankly, a massive lightbulb moment. You can trace the exact logic, starting at level 1 with just a single constraint shaping activity, moving up to level 4 where entire webs recursively alter each other, all the way down to level 6 where a completely new regime starts laying down rules for its own components. It shows exactly how minimal, blind relations form the literal bedrock of incredibly dense biological, ecological, or social systems. Section 5. Systems in the Real World. RCR in Action. Let's step out of the abstract theory for a minute and bring this down to Earth. In biology, RCR provides an unbelievably powerful lens for understanding health and disease. Take cancer, for example. We see RCR in how a tumor actively reshapes its surrounding tissue constraints. The malignant cells literally change the physical and chemical structure of their environment. And that newly reconstructed environment then dictates how the cancer can subsequently grow or evade the immune system. It's a deadly, closed loop of recursive constraint reconstruction. On the flip side, tissue regeneration relies on cells rewriting their own mechanical and bioelectric constraints to organize a healing response. Zooming way out to a planetary scale, we see RCR fundamentally shaping the entire history of the Earth. Life itself didn't just passively survive in its environment. Early biological activity, like cyanobacteria, actively pumped out oxygen. And this wasn't just a random byproduct, it fundamentally and recursively altered the atmospheric constraints of the entire planet. That brand new chemical constraint completely changed the trajectory space for all future evolution, paving the way for complex, oxygen-breathing life. The activity literally rewrote the rules of the game. But hey, we don't have to look at billions of years of evolution to see this. We can just look at our own social lives. Interpersonal relationships are built on what the paper calls coupled RCR. Think about it. Your actions today change the expectations, the trust levels, and the behavioral boundaries of your partner. Those newly reconstructed psychological and social constraints then dictate how you both interact tomorrow. You are continuously, mutually reshaping the trajectory space of your relationship through every single interaction. So as we wrap up this explainer, I want you to think about your own habits, your career, your relationships. What does your trajectory space look like? The truly brilliant insight of RCR is realizing that you aren't just moving through a fixed, rigid world. Your daily actions are actively carving the riverbanks of your own future possibilities. Every single action you take is reconstructing the constraints of your tomorrow. So I'll leave you with this. What kind of architecture are you building right now? Keep learning, keep questioning, and I'll catch you in the next one.